Welcome to another teardown video. This time it's another HP, a Vector Voltmeter 8405A. And this fantastic thing covers a frequency range all the way from 1 megahertz to 1000. Yay! That is crazy. And it's really old. Since it's a vector voltmeter, what it does is it measures the phase difference between two input signals. And it can also measure the amplitude all the way from 1 volt and all the way down to millivolts. Look at that range. So this is an 80 dB range. Then you just simply check A or B channel, and then you see the RMS voltage. So the other one shows the difference in degrees on the two input signals. And here you adjust for the phase ranges and zero the range and all that. I didn't really plan to go so much deeply into how this works and how you operate it, because there are many other videos on YouTube that already covers how this instrument works and how you uses it. But what I want to do is first I want to test if this works or not, just briefly works, and then we're going to tear it down and see what is inside. So that is the idea about this video. Now we'll power it up, see what happens. As always, I promised to video when I power on something. And yes, mains is connected. Ready. 32 watts is not that bad. For such a big instrument, I would expect this to be around that. Okay, so if I put this about 10 megahertz, A or B input, see the probes are here, so nothing is connected to the probes. I see some noise here, but I don't see input signal. And this is the range of input. Aha. Okay. We have a definitely. Oh, we also got a sticky meter. So that is one of the problems. This noise. Where is that coming from? Because I'm in now 1 volt, so it can't be that bad, can it? When there's nothing. Yes, look at that. See? Finer and finer phase range will create a lot of noise. So far, so good. All right. And this is the meter offset. Yeah, okay. Yeah, I expected that. So 0, and we should be in the middle. In this kind of light, you can really see how bad state this meter is in. Is this moisture or sunlight or something? Oh, this is sad. Other than that, it looks really nice here on the outside. But the display, the meters really looks bad. Oh no. Well, let me get a signal generator and input some signals carefully, because this one cannot handle that much. This is very important to note. Only 2 volts peak. DC 50, so that is crazy. It accepts a lot of DC. Alright, let me see what happens. Alright, I'm starting to test this thing a little bit. What I'm doing is 10 megahertz, 100 millivolt RMS. So that's actually what I'm just inputting. I don't really care about impedance, load, whatnot, what have you. So it's not that important. The thing is, I don't get any readout on the meter, on the input meter. So I guess maybe it's the input meter. But what I do get is this LED, or this indicator is now turned off. And you see, I have a 10 megahertz signal. And when 10 megahertz is inside this, look, ooh, and again, so what, 10? So it's maybe a much wider log range. But if I turn off the input, look at that. Now I turn off the input, we have indication. So that means it is actually responding to the input signals, but I don't see anything on the meter. So what I'm gonna do now is try and connect the same signal on both of the input and see if this noise goes away. You gotta see this, guys. All the problem is, it's this thing. This is, see? So this is obviously only the readout for the meter. Now it works. It's 300 is full. So that is 100 millivolt RMS. And this is what I got on my generator. And here we have 0. Let's trim this for 0. 0 degrees difference. I connected 2 signal outputs at the same time, and here is the phase difference on one of them. 1, 2, 3, and yabba dabba 3. So let's look at this meter, and then let's do 4, 5, 6, 7, 8, 9, 10, 11, 12. Isn't that amazing? And I can, of course, go down the degrees. So that was 0 again. Minus. All the way to minus 18. So yeah, the damn thing works. Except for the meter readout here and a little bit of a sticky needle. But yeah, basically, this thing works, and this is at 10 megahertz. How about we try if this will work at 500 megahertz or something? Yeah, and this is exactly what I expected. Of course, now I have 500 megahertz input, and I am in 18 degree full. So this is quite sensitive. All right. And look again. If I dial this up, of course it will accept 500. There's a little bit of... And obviously, wouldn't you expect this? All these hanging and dangling air wires with 500 megahertz. Wouldn't you expect this to be sensitive? See if I touch one or the other one. Ooh. Of course it's gonna be that sensitive, right? Let's just... Now my hand is over here. I try not to move, and then I dial the phase on the generator. 2, 3, 4, 5, 6, 7. So that means this thing is actually working. Click. At 500 megahertz as well. I can't really generate anything with variable phase difference more than 500. That is so lame, I'm sorry. But I think this works. Hey, now it's time to open this. Let's tear it down. So, mains connector is detached. The first 4 screws out. And as always, I save the screws for later. Those are special. See? This inchy crap. So how is this? All you have to do is pull back and then... Oh, what the heck is that? Wow. Even the inside is really, really sexy color. Nice, I like it. Hey, stay down. What have we got here? Oh, yucka yike. That smell is amazing. I need to open that window. But it is absolutely beautiful. And what do you see here? Oh, this is just pure happiness and joy. Look at that. This is the board that you can use for all the different plug-in modules. So you can lift them up and play around with them and repair them. It is of course stored in a really nice way in a spare socket. So this is extender board for service. Is this always included? How cool is that? I love it. So this one we definitely need to look at. So now we can take them up and have a look. What is what? So this is also one of the good things about video recording when you disassemble stuff. Just do it really, really fast and yeah, to whatever detail you feel is needed. But this will reveal the different boards. Where are they? So you can easily put things together without the manual and such. And I see all those modules here, they look a lot like the same. Aha. Ooh, you can just... Why are you stuck, you sucker? Oh, here you go. That was easy. So what are they doing here? They're connecting all the pads in parallel. Really nice double layer board. So, and this is exactly what I would have guessed. Low frequency. Wow, look at the tracks, really nice and wide and gold plated. And they write the voltages so you know what you're doing. Really big silk screens. Super, super good. I love it already. This is going to be easy to figure out what is what. And here, let's have a look. So this is the number down there for the number for this PCB, and I guess you will find this number. No. Why don't we find this number? Oh, it's up here. So let's see again. 84. 405, yada yada yada. So this is exactly the number. So that means the other module that is exactly like that is numbered 06. Oh, look at that. Isn't that just sexy? Would you do that today? No, this is not the same. This looks a little bit different. See? It is a little bit different. So this is line 1. I would expect to find two exactly identical boards. But anyway, now I know I can just pull up anything without being scared. .603, and again, aha! Those are called exactly the same. So what we have down here is the same number for the two boards. And again, so those two boards will be exactly identical. Aha! They are really, really nice too. So where is all the high frequency funky monkey? This is just a power supply. Yeah, it looks definitely like a power supply. -20, +20. So that is what it's doing. Ooh, this looks a lot like they stole the Philips design I've been playing with the last few weeks. The two identical power supplies, and then they just connect them, positive, negative, and everything is just completely the same. Don't you just love it? And those transistors, aren't they just sexy size? That is nice. Sprague, super good quality. And no leaks, of course. When you do it right, you only need to do it once. You see? Real good high power regulator down there. Big capacitor here. Let's have a look. There's another one. So this is of course for the negative and the positive supply. The two. So there will be some... yeah. There will be some power rectifier diodes and stuff. Probably on the other side. So we need to stop pulling out boards. We need to look at the bottom, but I can't wait. I need to look in here. Some stuff. So let's just... Ooh, I don't like that sound. Let's look at the different voltmeter thingy. Paired. Oh, look at that. Let's move this carefully so we can see what they're right. Can't we get some light? Come no, man. Yeah, here we go. So this is a thermal thingy you can buy and then connect your transistors so they're good thermal. So this will be the first and fast. Oh, I don't like the sound. Why is it so stuck? Frequency, adjustee, symmetry. I see only really nice components. Everything here is high quality. Ah, come on. Search speed. One mega ohm. No, 1 point. What is that? Micro? Maybe we do a little bit of... Come on, man, it's... I really need to pull with a half a ton here. But this cased design here gives perfect isolation. This is a really, really good way to do good quality products. So if you're one of those hi-fi dudes doing high-end, high-quality audio stuff, build your stuff like this, and it's gonna be fantastic. Yeah? Now, what is this module doing? $609, yes. Boring. But we want to go in there. What is in those? Okay, I get a screwdriver and then we'll get back. Now I took out the screws, and here's another little detail. I just add those little marks, so it's easier for me to assemble stuff back without looking at my own video. So, was that it? Some funky stuff down there. I'm not totally impressed. Is that really it? Now I'm missing those. Oh, so we need tools to pull them up. Ah, look what they have done. Here at the sides. They got those really good contacts on both sides here. So it's really difficult to pull them up. So this is a DC port here in the middle, because this don't have this probably. Oops, super duper easy to pull up. And again, let's double check. Numbers match. So that means I will be able to put it back. 13. Okay. I don't really see anything fantastic about that board. So in here we'll have some fascinating things. Oh, they're not supposed to come up. Look at that. Oh, look at that. What the heck are they doing down there? So that will be the end of coax cables, right? And it goes up here to this connector that is now sitting up a little bit higher. And then they pulled the pins so you can solder on them. Oh, they are nasty. So that is how they can do something that is working really fast. But here, again, feed through capacitors. Again, they're in the connectors. So that means I should be able to pull it up. But it's... I was really... Oh, I need both hands on them. Let's see if I can get it off. They're super hard to pull out. Those boards. Don't you just love the way that this is this must be the input. So this is called gain adjust or symmetry adjust, but I guess this looks like the input stage and a preamp of something. Because why would you have all this? Looks a lot like input protection. I like the gold-plated PCBs. Why aren't they gold-plated on the other side as well? A little bit funny, isn't it? And the trimmers with different colors. Look at that. And they are also different values. So the red is 10K, the black one is 50K, and the green one is 500. So I found another one here. But this is 200. So that was that one. This is the first. And the boring one is the center one. Look at those green pearls on the capacitors. Aren't they just cute? Just to hold them up a little bit over the PCB so it looks really nice. Huh. I like it. So that is really cool. I think it is time to look on the other side. Oops. Let's look a little bit down here behind the meters. The assembly work and the mechanical solution is just top of the pops. It's just so beautiful made. This is the mains switch with the resistor for the, I guess that would be a neon indicator because it's blinking like a neon indicator. This one is a bulb, so you can easily change that. This is the frequency range dial. I don't really understand why this is done with resistors and coax cables. What exactly is going on here? And also what I noticed, I'll see if I can get a really nice close-up picture. See, some of the resistors, they got numbers like that. What the heck is that? Please tell me if you know, because what I can see here is 1% resistors. This is all 1% resistors, right? But then see, some of them, they got some numbers. Ooh, this is expensive stuff, yeah? We are now looking at the bottom. I took out the 4 screws and pull back and lift up. Super easy. Ooh, that is actually really cute. They glued this together so no dirt and stuff can get in it. That is pretty cool. That's a good way to treat a pot meter so it's completely closed. And of course this is a spare. And also if you're smart, this is a spare socket. If any of the sockets broken, you can also steal this one. So yeah, the inputs. So it was input protection, exactly as I thought. So this is doing some magical things with the input. And here we have one of them goes into a delay, and on the other side there was a screw to adjust this delay. It's actually also written on this one. Yes, delay line SE. Can't we see this? Delay line. So you can trim this a phase adjustment. So this is where you delay one channel so it fits the other one. This is how you can go to 0. Ooh, see the other one. The cable from the other one goes here, back and forward a little bit, creating a delay that is obviously in the middle of the adjustment range for this one. That is nice. So now we can trim this. So here is the inputs. Here we have some voltage, and then yeah. And then what is doing what here? I'm actually just guessing here because I have really not a clue. Everything here is pretty nice. I would have expected these to be secured mechanically, because see, they're actually hanging in the solder like this. This long wire here. Really? But it don't look like it's a problem. Look at this. wire just hanging in the solder. So some wires are probably DC and stuff, so they can put them together, but this is something that you don't want to be interfering with some other stuff. Where are the bridge rectifiers and the rectifiers and anything like that? All I see here is the capacitors. This one is where the heck is that? Did I really miss them looking at the power supply board? So this is all the mains stuff comes here. Where's this orange one? Where's that? Just goes into, okay, it's here. Great. So that means all the mains windings goes in here. So I would expect to see some rectifiers here. But anyway, it is really looking nice, and my problem is in this one, I guess, or in the meter amplifier. What we could do is try and this is super cool. We could just take this meter switch here, and then it goes from that one. This is the AB, and that means which one are you looking at, because it's not affecting the real measurement. So all this is meter stuff, not what is going on with the phase comparing and the phase stuff. This one didn't really seem to have any, it didn't affect the phase. That comes somewhere. Where is this one going? Ooh, that goes in the other end. Maybe we should have a look at this. I guess this is just a shield around some decked switches. But I'm really curious. This is the whole idea about those teardown videos. That is to see what did they really do, huh? So since this one is so shitty, I need to look in here anyway. I'm probably going to regret this, because see what is going to happen now. When I unscrew this, everything here is going to fall to the floor and get lost. And then I don't know if I can get in here. Ooh, yeah. Look what they're doing. Oh, I need to screw this. Yep, exactly. What did I say? I already regret it. This thing is very difficult to remove. It's going to be fun to assemble again. Anyway, because it's so flexible, I was able to bend it that much so I could open it and pull it out that way. So now I can see all the different things in here. It's really not that easy to put light in here, but you see resistors again. Those nice resistors with numbers on them. And diodes and capacitors and what have you. What is the idea? I thought this was the attenuator. Hey man, why is it so... How can this be broken? So that means some of those diodes are blown or what? Hey, and this is just the AB switch. How can it look? How can it be so nice then? Yeah, that is really going to be a lot of fun to get this up and running. And also I need to take out the meter and see if I can get the needle to move correctly. I think I will just desolder those two wires for the meter and then play with the signals here. See, they come from here. I really think it's nice with all the different colors on the wires. See how easy it is to figure out what is connected to where without having the manual or the schematics or anything. It is just really, really easy to figure out. So all those are, of course, power supply. Look how it's the way that it's grouped around, and then it goes here and there and whatnot. And again, feed through capacitors. Yeah, really, really nice. Here it is again, the power supply and rectifier board. Look again, diodes and series resistor, 1 ohm. This goes out to the big capacitor here and the big capacitor here, the positive and the negative side. I really think it is a super good idea going through resistors, because this way your peak current to your capacitor will be much less. You'll have a much more smooth system, and lower ripple currents also means lower emissions from the cables or the capacitors and all this stuff. So that will be, of course, less pickup of this hum in any other circuits nearby. So this is a really good trick. I really wish a lot more people would use. So this is the 40 watts that this unit uses. Go through those 4 tiny diodes. Isn't that amazing? Of course, this is plus minus 20 volts. So it's just 1 ampere and 1 ampere. And then you have 40 watts. Now the unit is switched on. Put in all the modules. And I'm of course measuring the AC voltage drop over the 2 resistors. And what I see here is this is the positive. Yeah, exactly. This is the AC side, and the diodes, they go this way. So this is the positive resistor. Oh yeah, well, the positive, and this is the negative, right? Let's see if I can hold this without creating any kind of smoke or flames. Okay, hang on a second. Yep. So 0.66, and then let's look at the negative. 0.4. So that's quite interesting. So that means this thing uses a lot more current in the positive. I know that I'm saying if you put resistors in series with your rectifiers, your peak currents, they get much lower. And that is of course correct. They do get a lot lower, and you do get a lot less radiation and magnetic coupling and yada yada. But look at this. This is this board. This is how it is connected, seen from the back. Okay. So this is the mains transformator. All those wires were just hard sewed together. All those, also the primary windings. This is a 120 volt primary winding, and this is also 120 volt. So they can be either in series or in parallel depending on the voltage switch. those three are secondary sides. So this is the positive winding, the center tap, and the two sides of that positive winding, right? They are the positive supply. So those three over here, they're exactly the same. Again, a center tap and the two sides of that will become the negative supply, the negative 20 volts. But see the wire, the colors of the wires. The purple here goes to the purple capacitor, and that purple wire goes to what is the minus 20 volt bus. And this is also the minus 20 volt output, and this goes all the way around the unit. Okay, so let's first look at the positive supply. The yellow orange goes to the PCB through the two diodes, resistor, and out to the capacitor. So here we have plus 36 volts, and this is just the capacitor. Fantastic. So they didn't take a wire from the capacitor and back again, but they just take this point that goes to the capacitor. And again, there are two wires here. It's not that easy to see, but two wires. One go to the fuse. Here on the back side, we got fuses for the positive and negative 20 volt buses. So this is for protection of everything. Really well thought. And then the 36 volts comes back into the board, but it also goes to the large transistor that you have seen on the sides, right? And then it is its base is driven by this one, and it's pre-driven with here, and we got the voltage comparator and all that stuff. And both of those sides, they are exactly identical, part by part, by placement, by connections. Everything here is super just the same, right? And the only place they connected them together was here. There's a track here, and this is the 0, 0, and goes to ground, and it goes to that point. So this is where they connect them in series. The fun thing about this, normally you would also have a mirrored negative, but they've done it the same way. They've done it exactly like you would have done a positive rectifier. See again, the center tap and the two sides. See the two sides of the negative, they're here. And they go to the two diodes and then creates a positive voltage. That is funny. And why would anybody do it like this? And this is because this design is really old. And those guys, they are used to create rectifiers with tubes, and they can only create a positive voltage with tube rectifiers. This is exactly why. Why the heck would you else do it like that? It is so much fun to see how this was done. So I think I will redo those wires, because I really don't like the way that primary side and secondary side and ripple currents goes directly parallel with supercritical DC output wires. It can't be good. This will couple, and it's really easy just to create two different lines of wires, and this way you have all your AC stuff and all your DC stuff just a little bit separated, and it will be fantastic. I think the reason why they did this is just for easy and fast manufacturing. So the wire harness that was just pre-made, and it's just thrown down here and put in all the wires, and then Bob is your uncle real fast. I hope you enjoyed this video. See you around. Bye.